Hi, welcome to Physics on Table channel. As in my previous video, I have discussed the syllabus of IIT JAM regarding solid state physics and electronics. Let Let us start today the easiest portion, digital electronics. Okay. So if you have watched my previous video, hope you know the syllabus now. Then we're going to start Boolean algebra today. So what is Boolean algebra? And what is this binary system, decimal system, octal, hexadecimal, and all? Okay, so let's start. At first, we're going to learn some conversions, that is, from binary to decimal, and so on. So let's study what is binary system, what is decimal system, when a system is called octal, and when it is called hexadecimal. Okay, so let's start. We're going to study types of systems. Types of systems. Okay, we have mainly four types of systems. Number one is binary. Second one is decimal, followed by octal and hexadecimal. Hexadecimal. Okay. In case of binary, number one, binary, the base is 2. Base is 2. Okay. And a binary number will consist of two digits, that is 0 and 1. Okay, for example, 0 1 0 1 1 0, and at the bottom, at the subscript, you have to write 2. This is an example of binary system. Okay, what is decimal system? Decimal system, the base is 10. That is, here you have 10 digits from 0 to 9. Okay, that is 0 1 2 3 up to 9. You have 10 digits. For example, 32 base 10 is an example of decimal number. Okay, next we have octal. In case of octal, the base is 8. So we have 8 digits, which are 0 to 7. Okay, that is 0 1 2 up to 7. Any example of octal? We have 5 6 2. Okay, at and the base is 8. Okay, next let's come to hexadecimal. Hexadecimal, the base is 16. So we have 16 digits, 0 to 15. Here we need to remember one thing, that that 10 11 12 13, we're not going to write this in hexadecimal. Okay, or in this type of systems. What we're going to write is, suppose in hexadecimal system we have a number 16 to 12. Okay, this is in hexadecimal. The base is 16, as I have already told. So I am going to tell you very important thing, kindly note it down. 10 is equivalent to A. Where there is 10, we are going to write A. Where there is 11, we are going to assign it by B. Where there is 12, we are going to assign it by C. Okay. Where there is 13, yeah, there is 13, we are going to assign it by D. If it is 14, we are going to assign it by E. When it is 15, we are going to assign it by F. Okay, I'm extremely sorry, I have written 16. 16 is not possible in this kind of systems. As the base is 16, we can't exceed that number. Okay, I am taking another example. Let's go to the next page. If it is hexadecimal, the base is 16. Let's take example of 11, 2, let's take 13. Okay, in hexadecimal we are going to write this as B2D 16. Okay, this is very important. Let's take another example. Suppose 11, 3, 14, base 16. Base is important. 11 will be B, 3 is going to be 3, and 14 is going to be E. Okay, this is the fashion we write this in this type of system. That is 11, 14, the number that exceed 10. I mean 9 in alphabets. Okay. In television, whenever you see you can see some of the codes, right? Some codes will just you can see in front of the television. You will see that it is written 00 F E C D, like in that fashion. Actually it is assigning that that alphabets are assigning that number. So that's the rule. People will need to understand this. So these are the basics for binary, decimal, octal, and hexadecimal, and the alphabets assigning in case of hexadecimal. I think this concept is more or less clear to you. Practice some of the questions. Hope you'll be able to grab it down. Okay, thanks for watching the video.